Hi, my name is Yancy Liao, and I'm a data scientist. I'm excited to present my project on Amazon grocery reviews. So why reviews? Customer reviews help a business answer two important questions. One, do customers like a product? And two, why? And I chose to do groceries because I thought they were a fun category of products. So the data set we had was over 1 million customer reviews from Amazon's grocery and gourmet food section. It included everything from packaged products to beverages to fresh foods. Here's an example of the 10 most reviewed products. As you can see, they have around 6,000 reviews. And the vast majority of these are different kinds of kind bars. So evidently kind bars are very popular on Amazon. I took the positive reviews for the most popular kind of kind bar and did some topic modeling with LDA. As you can see, topic 0, we have sugar, good, low, bar, favorite, yummy protein. This probably indicates that people like this product for being healthy. If you look at topic 1, you see, delicious, flavor, excellent flavors. So these are probably people who like the bars for tasting very good. And topic 2 is all about chocolate, dark, nuts. So this is probably the particular flavor that these reviews really like. So a business looking at these, doing a topic modeling of the positive reviews can tell them why customers are drawn to a product. On the other hand, if you do some topic modeling of the negative reviews, you see, for example, topic 0, Amazon purchased bars. That's a little bit unclear why it's negative, but then there's like tooth here. So maybe it has something to do with the quality of, or like how chewy the bars are. Topic 1, you see that there's box, stale, hard. So clearly there's a group of customers who dislike this product because of the staleness of it. Looking at the actual textual reviews across all of the grocery category products, we see that most reviews are very short in length. They typically have less than 20 words, whereas the ratings are extremely skewed towards the positive sides, like 4s and 5s. We want to define our task in doing sentiment analysis. So the task is predict whether a review sentiment is good, which is a 4 or 5 rating, or bad, which is a 1 to 3 rating, just using the text. And we wanted to subset 150,000 reviews just for the sake of time. And we created a target vector with 1 for good ratings and 0 for bad ratings. And so roughly 85% of reviews were good and 15% were bad. And the candidate models we used were naive Bayes, logistic regression, and XGBoost. So first we had to do feature engineering. We chose to do a TF-IDF vectorizer with n-gram range of 1 to 2 and a max vocabulary of 10,000 words. And to deal with the 85 to 15 class imbalance, we tried just random sampling the 150,000 reviews, which is just basically doing nothing to address the class imbalance. We tried under oversampling because we have so many different reviews that we were able to do that. And also SMOTE, which is synthetically creating like new examples of the minority class. And so we see that when we compare our model performances, the upshot is that the logistic regression seems to do much better, to do better than the rest. And so if you look at this logistic regression row, it generally has higher performance metrics for all 3 of the different class and balance strategies that we tried. And to look a little bit more closely, we see that when we do random sampling, the precision is like 0.98 and recall is 0.92. So precision is much higher. When we do a class imbalance strategy like oversampling or SMOTE, we see that it sort of reverses. The recall becomes like 0.97, the precision becomes 0.85, so they're sort of switched. Hold on, let me go back 1 second, please. So to interpret in a business context, we would want a high recall because we want to get we want to make sure that we want to classify all the bad reviews as bad, because it's more important than looking at all the good reviews. So we want a high recall. And in that case, we see that Smote has a very good trade-off of precision of 0.88 and a recall of 0.96. So even though the F1 scores for like Smote and under and oversampling are lower than for just random sampling, given the fact that a recall is more important in a business sense, it means that we want to use Smote. So at the end of the day, logistic regression plus Smote was the best combination. We also wanted to take a look at examples of where the classifiers were extremely wrong. So here are the reviews that are most wrong according to the predicted probabilities. They were the most wrongly classified as good. So you see that there's these are a lot of reviews that are sort of on the borderline. Like they say, not great, nothing great. So they have the word great in it, and so the classifiers classify them as good, but actually the not makes them bad. And then on the other side, you see that there are reviews that are wrongly classified as bad, but are actually good. For example, this one right here says okay, but still weak, and they nevertheless gave it a score of 5.0. And decent but bland, but they nevertheless gave it a review of a rating of 5.0. And this one I really like. There were a few gross flavors, but overall not bad. I bought it for the free, probably free something, but they nevertheless gave it a 4. So conclusions. So we perform topic modeling on a product reviews to get why customers like or dislike a product. We do sentiment analysis to get whether customers like a product. The best performing model for doing sentiment analysis was logistic regression with Smote because it gives the best recall. So a lot of the wrongly classified reviews were because of negated statements and things like that. For future work, we want to use neural network models like LSTMs because they provide the most cutting edge performance, and we want to use pre-trained word embeddings to get stronger feature signals, and also we want to train a larger sample size using GPUs. So that's it for my presentation. Thank you for your attention. Let me know if you have any questions.